All right, today's lesson, lesson 69, we are solving logarithmic equations. Now we're going to begin, example 1 is an exponential equation. So we're going to start with review. What we would do with this, we want to get the bases to be the same. So I would rewrite the 4 as 2 squared to the power of x still equals the 1/2 to the power of x minus 3. Bases are still not the same. So I could rewrite now this 2 as 1/2 to the power of -2, because when you move me, you change the sign of the base, you change the sign of the exponent, all still to the power of x. And now when you clean this up, a base to an exponent, the rule is keep the base, multiply the exponents. And now, once you have one thing on the left, one thing on the right, they both have the same base, then that means the exponents must be the same. So negative 2x must equal x minus 3. Subtract an x to both sides, we get negative 3x equals negative 3. So x must be 1 in this case. Again, that was review. Now, what we're really doing in this lesson begins with number 2 here. We are solving logarithmic equations. Same general idea applies. In this case, I've got one logarithm on the left, I've got one logarithm on the right, one thing on the left, one thing on the right. They are both log base 5s. So therefore, the first one's argument must equal the second one's argument. So 4x minus 7 must equal x plus 5. And now solve for x. So just linear equations, put my x's on one side, put my constants on the other side. In this case, we get x equals 4. Now, is that our answer? Maybe. Okay, we talked about it several times, but we haven't really done anything with it yet. But the argument of your logarithm must be positive. That does not mean x has to be positive. It says the argument has to be positive. So when x is 4, come up here and look at your argument, which was 4x minus 7. When I plug 4 in, 4 times 4 is 16, minus 7 would be 9, positive. What about the other argument? 4 plus 5, 9, positive. So the argument itself is positive, so x equals 4 is our answer. Next problem. Now this one's a little trickier. Because of that plus sign, I've got 2 things on the left, 1 thing on the right. You cannot just say 5 plus 3 equals x minus 2. That would be wrong. You have to apply the properties that we were talking about here in the recent days. If I have 2 logs separated by a plus sign, I can consolidate them as a single log, multiplying the arguments. So the 5 times 3 gets me 15. Now I've only got 1 thing on the left, 1 thing on the right, and once there's 1 thing on the left, 1 thing on the right, They are both log base A. I can set the arguments equal to each other. So now I can say 15 equals x minus 2. And solve. And we get x equals 17. Again, when you're solving logarithmic equations, you must check to make sure your answers are acceptable. X equals 17, doesn't matter whether x is positive or negative. The argument must be positive. So when I come over here to x minus 2, 17 minus 2 is 15, it's positive, it is acceptable. Number 4. Again, I've got 2 logs on the same side of the equal sign, this time separated by a minus. Okay, that tells us we can consolidate them as a single log, in this case natural log, dividing the arguments. So x plus 6 divided by x minus 1 equals the natural log of 5. One thing on the left, one thing on the right, they are both natural logs, which means log base e. So set the arguments equal to each other. So x plus 6 divided by x minus 1 must equal 5. Now at this point you can think of it a couple of different ways. Some of you would choose to multiply both sides by x minus 1 to get rid of fractions. I usually just put it over 1 and cross multiply. Does not matter which way you think about it. You're going to end up with that as your next step. So, doesn't matter which way, we get the same thing. Now, again, it's a linear equation. Put your x's on one side. I'm choosing to put the x's on the right. Numbers on the other side. And solve for x. Now, this time we got a fraction. Can we have a fraction? Of course, fractions are numbers. Now, the question, though, is x equals 11/4. Well, 11/4 plus 6, what's a positive number plus a positive number? Definitely going to be positive. That's acceptable. What about 11/4 minus 1? 11/4 is bigger than 1, so 11/4 minus 1 will still be positive. That is acceptable. So that is our answer, assuming we did all our arithmetic correctly. Alright, next problem, number 5. Now I've only got one thing on the left, and I've only got one thing on the right, but this time I got that extra 3. That 3 is screwing things up. It's in the way. How do I get rid of it? Well, we have a property that says when it comes to logarithms, you can take the coefficient and move it to become an exponent. So we've got log x cubed equals log 8. Now, one thing on the left, one thing on the right. Both log base 10, they're both common logs. So set your arguments equal to each other. We have x cubed equals 8. And I'll solve this. Alright, now, in this case, we can do this a couple of different ways. Okay, one way is to go back to what we were doing with our exponential equations. I could think of this as x cubed equals, and rewrite 8 as 2 cubed. In this case, the exponents are the same. Since they both have an exponent of 3, then that means the bases have to be the same. So x must be 2. Or you could have simply taken the cube root of both sides. if you took the cube root of both sides, the cube root of 8 is 2. We get the same answer either way. Doesn't matter which way you look at it. And again, we get x equals 2. You go back and you double check the argument, and the argument this time was x. So that works. All right, number 6. Now this time, there's a log on the left. There is not a logarithm on the right. My x is in the argument. I am stuck. Remember, when you get stuck in one form, change it to the other form. Right now, I am stuck in logarithmic form, so change it to exponential form. So, the way we would do that is the base of your logarithm is the base of the exponential. What the logarithm equals is the exponent. And that will equal the argument. So we have changed it from logarithmic form to exponential form. Alright, now that's the way we did it a few days ago. If you want to keep doing it that way, keep doing it that way. I'm going to erase. Now notice what we have here. I'm going to end up with the same thing. I'm going to do it a different way this time. I'm going to do it algebraically. Okay, just like if we had a square, I would do the inverse operation and take the square root. If I've got plus, I do the inverse operation and subtract. Well, in this case, I've got a log base 4. The inverse exponential would be the inverse operation would be an exponential base 4. So what I'm going to do is an exponential base 4 to this side, and exponential base 4 to that side. On the left side, the exponential base 4 and the log base 4, they all cancel, leaving me with 5x minus 1. The right side is just 4 cubed. Now notice, that's the exact same thing I had before. It's just a matter of which way you prefer to think about it. So, moving forward, I tend to do the algebra though. So at this point, 5x minus 1, what is 4 cubed? That's 1. And then now, 5 by 5. So x is 13. Now, is that acceptable? You come up here to the 5x minus 1. 5 times 13 minus 1, definitely positive. So that would be acceptable. Alright, now number 7. This one looks a little different also. Now this one's not even a logarithmic equation. It's an exponential. Now, based on how we did our exponentials, we would want to rewrite that 11 with the base of 4. And if we could do so, that would be great. But, obviously, we cannot write 11 as a base of 4. That's the problem. And we are stuck. But when you are stuck in one form, change it to the other form. So again, if you prefer to do the conversions, do the conversions. I tend to do the algebra at this point. So to demonstrate the algebra, I'm just going to rewrite this. 4 to the power of x equals 11. Since this is an exponential base of 4, what I will do is a log base 4 to both sides. Do a log base 4 over here also. Now, my log base 4 and exponential base 4, they all cancel, leaving us with just x equals whatever log base 4 of 11 is. Now the problem with that, I don't know what log base 4 of 11 is either. And my calculator doesn't know log base 4. So that forces us into the change of base formula. Now you can either do You need to do something that your calculator knows. Okay. Your calculator knows log base 10, your common logs, log base e, your natural logs. It does not matter which one. Okay, in this case, let's go with the common logs. So it would be log base 10, which I'm not going to write, of 11, divided by log, same base 10, of 4. And then now, reach for the calculator. And I can do log of 11 divided by log of 4. X is 1.729715809. So, rounding to 3 decimal places, it is approximately 1.730. Now, this time, our question was an exponential equation, so there's nothing to really even have to check with that. It's only with logarithms that the argument must be positive. And now number 8, last one. Again, we got a plus sign here. So my first step, consolidate. Okay, we have a log, base 10, understood. But my argument is going to be 8x being multiplied by x minus 20. Now that still equals 3. Cleaning that up a little bit. I've got this log of 8x squared minus 160x. But I've only got a log on the left. I do not have a logarithm on the right. Okay, this is understood, base 10. So what I'm going to do, just like we did on problem 6, since I have a log base 10, I'm going to counteract that with the inverse operation of an exponential base 10. What you do to one side, you have to do to the other. On the left side, the exponential base 10 and the log base 10 cancel, leaving simply 8x squared minus 160x equals. On the right side, do the arithmetic, 10 cubed is 1,000. And now, we no longer have a logarithmic equation. What kind of equation do we have? 8x squared is a quadratic equation. How do we solve a quadratic equation? Several methods, but the main two would be factoring or the quadratic formula, both of which require set equal to 0. So, let's set it equal to 0. And now it's up to you which way you want to look at solving this. Me, I'm going to do factoring. First step with factoring, GCF. Pull out the 8. I'm left with x squared minus 20x minus 125 equals 0. Now, got 3 terms in parentheses. Looking for a perfect square trinomial. Negative 125 is not a perfect square, so that forces us to the general trinomial. Now for negative 125, that's pretty easy. It's got to be a 25 times 5. And since I'm looking for a negative 20x, it's got to be a minus 25 and a plus 5 would be the correct grouping. Once you have it factored equal to 0, set each one equal to 0. So 8 equals 0, x minus 25 equals 0, x plus 5 equals 0. That doesn't make any sense, throw it away. So in our quadratic equation, we get 2 answers. But there's a catch. Again, we were solving logarithmic equations. Okay, doesn't matter what x is, can't seem to see both. Doesn't matter whether x is positive or negative, the argument must be. So starting with x equals positive 25. What is 8 times 25? Positive number. I really don't care about the actual arithmetic. What is 25 minus 20? Positive number. So that's acceptable. Okay, what about x equals negative 5? 8 times negative 5, that's going to be a negative number. For your argument, not acceptable. So even though we got this algebraically, we throw it away. I want to emphasize, it's not because x equals negative 5 that we are throwing it away. It's because the argument was negative. That's why it has to be thrown away. And in this case, only x equals 25 is our answer. Okay. That was lesson 69, solving logarithmic equations.